Greetings, detectives, crime solvers, mathematical wizards. Today we're going to solve some mysteries. We're going to have a few clues given to us about some circle, and we're going to try to gather that information together and figure out exactly what circle it is. That's our goal today. So we're going to be writing equations of circles kind of based on clues or facts, rumors, things like that. So we've got to gather all of our facts together. Let's see. The first thing, the first problem I want to do is write the equation of a circle if the endpoints of a diameter are the following. Let's say I've got the point -2, 6 and 10, -10. Alright, so I've got a couple clues here, and the question is this enough information to narrow it down to a single circle? So, let's see. When I write the equation of a circle, what facts do I know? What facts do I need to have that equation? What defines a circle? What elements does it have? Does it have a slope and a y-intercept? Do I need the circumference? Do I need the area? Midpoint. What's the midpoint of a circle called? Oh yeah, the center. Man, I was just going to call it the radius, so I'm glad you corrected me. So I would like to know the center, so that's currently an unknown thing. Well, is the center going to be either of those points? No. No, those are the endpoints of a diameter, so no. In fact, the center is as far from both of those as it can be without getting closer to the other one. It's true. It's true. The other fact that I'd like to know is the radius. So let's think about how I could use these clues to gather this information and then write the equation. And if I wanted to, I could even graph it. Or you might even want to start with a graph, plot those points, and then see if you could kind of figure out the situation from there. That's not a bad idea, actually. Not bad. Yeah, let's actually do that. I figure if it can be an entry point for some other people, more visual learners. Let's see, -2, 6, and 10, 10. Okay, let me grab, -2, 6, and 10, 10. I think these are going to be mostly in that quadrant here, and paste. So let me just draw a picture of at least what we've got going on, and then we'll see if we can figure out the whole situation here. So, just to help people visually understand what's happening. So -2 up 6, there's 1 point, and over 10, oh wait, darn it. It's okay, guys. We're good. We're fine. We're good. We're good. Let's see. Here we go. Here we go. I have to. Yeah. I clearly thought that was going to be going in the other direction there. Let's see. And here's a graph that'll fit space for us. But notice, actually when drawing the graph, it is kind of important to figure out the ballpark area where your graph is going to exist. So that way you can kind of like zoom in on the right spot. So let's see. So those are my two endpoints of a diameter. All right, so I know my circle is going to be something like, I don't know, like that, right there. There's my circle-ish, right? Endpoints, something like that. My center is probably around here or something. So how could I find further information? What would help us? No? No? Well, how could I find the center? Where would you describe the center between these 2 points? Right in the middle. Do I have an equation to help me? Distance formula would give me the length of the diameter. The midpoint formula would give me a point that actually is what I'd want. So let's see, midpoint formula. I'll give us the formula again. It was x1 plus x2 over 2 and y1 plus y2 over 2. So that's the formula that I'll use, which I described, by the way, as the average of the x's and the average of the y's. So let's see, our center is going to be, well, I don't know if I like equal signs there, but is going to be, let's see, -2 plus 10 over 2. And 6 plus -10 over 2. So the average of the x's, the average of the y's. So I will get, let's see, that'd be -8 over 2 and -4, yep, over 2. All right. And I shall have -4 comma -2. Voila. So if you want, you could even, I don't know, you don't have to write it up there. I just like to write down what clues we're looking for. Oh, you know what I did? Where's my mistake? Did you spot it yet? Yeah, what? I don't know what mistake you're talking about. I don't see a mistake. What are you talking about? There's no mistake there. We're good. Yeah, 4 -2. We're good. Yeah, so you guys were right. I made a sign error there. Bam. 10 was more influential, so it's +8. And actually, that sort of intuition is valuable, and that's why the graph would have been helpful. Because, like, if I didn't graph it, I'd have been like, all right, my center's -4, -2, and then, like, maybe would have just rolled with it. But clearly, -4, -2, it's like this would not have been the midpoint of those two there. So there's my center, my h comma k, even if you want to think about it that way, right? H and k. How could I find my radius? Actually, give me 2 ways I could find my radius. If I tried to write it in standard form, I still wouldn't know what my radius was, although you actually do have a really interesting point that I didn't think of at the moment. I actually could write the equation in standard form. I could plug this in for h and k. I could plug either of these points in for xy, or this one for xy, and I would be able to solve for r. So that's kind of like back in the days of y equals mx plus b, where they'd give you a point and the slope, and you'd have to find the y-intercept. You just plug in x, y, and m and solve for b. You could actually do that. However, in this case, because I know some points on the circle and I know the center, the other technique I think might be quicker, although actually, you know what? It's kind of doing exactly the same math anyway, because the equation of the circle is the distance formula, essentially. Yeah, I would just do the distance formula. What 2 points would you use for the distance formula? Yeah, I'd use the center and then either of these, that guy or that guy. You technically could have found the radius first if you did that and that. And then what? Divide by 2, right? Because the radius is half of the diameter. So lots of options. I might use my first endpoint because those are smaller numbers, so -2, 6. So my radius is going to equal the square root of, let's see, x2 is, I'll call it -2 minus 4 squared, plus y2 was the 6 minus the -2. You don't have to set it up this way. You could have called this 0.2 and then that other one 0.1, doesn't matter. There you go. And let's see, so -2 minus 4 is -6, plus 6 plus 2 is 8. Oh, this one's going to be a larger radius. So that's 36 plus 64. All right. Okay. Yeah. It's 10. Thank you. That's quite the sneeze. I'm not sure if that feels like 10 to me. Yet. Well, does it? You think... Is that distance the same as this distance? Yeah, okay. I guess. All right. It feels like 10 then. So let's see. I can actually, I could have technically drawn the equation of my circle a while ago, but it would have looked something like that. Bam. And let's see if we can write the equation now. So the radius is 10, the center is -4, -2. So the equation will be x minus 4 squared, all squared, plus y plus 2, all squared, equals 10 squared, which is 100. And we have found our culprit. Mystery solved. Dun dun dun. Right? So that's the idea. And notice once again that this is the opposite of that, and opposite, right? So good stuff. All right, are you guys ready for the ultimate mystery? It turns out, well, let me ask you guys, how many points do you think would be the minimum amount to find a specific equation of a circle? Like if I plot 2 points, is that enough to draw a circle? Is there only one circle that would ever pass through those 2 points? No, there'd actually be infinitely many. Because those don't necessarily have to be the endpoints of a diameter. I could have like a giant circle. Let's see, I don't know if I can actually accomplish this, but I could have a circle, you know what I'm saying. Ah! Like I could have a circle that's kind of like barely hitting both of those, if I could land it right. Yeah, something like that, Or it could have been a tiny circle that's like hitting both of them or something, Or it could have been that it was the, that was the endpoints of the diameter. However, let's see, if I have a third point, could I draw a circle between all 3 of those points, you think? Do you think this third point would have to be in a very specific spot for it to, like, could those 3 points make a circle? Like, could I draw a circle through these 3 points? What do you guys think? It would be a huge circle. Let's actually, let's see. It would be, yeah, a ginormous circle. Oh, that's odd that didn't work. I thought those points were defined to be on the coordinate plane, but they were not. That's funny. They were like invincible to coordinates. But yeah, so like those 3 points would be able to define a circle. Notice, no matter where my third point lands, I can actually have a circle drawn out of them. Except, well, this is like an arc. Imagine the rest of the circle being drawn there. Use imagination. Imagination. Let's see. Actually, let me, maybe I can just construct a secondary arc. And, well, you get the idea. I can, well, whatever. I don't care about the dotted line. Or dotted arc. So notice that my third point defines the circle perfectly. Is there any location that I couldn't put this point that I wouldn't have a circle? No. Yeah, if I put it truly in a line, if I could actually accomplish that, oh, you saw that for a second there, no circle would exist. Because I can't draw a circle through 3 collinear points. But as long as it's anywhere else, I could have a giant circle, I could have a smaller circle, right? All sorts of stuff. So any 3 non-collinear points make a unique circle. All right? There's only one circle that's going to pass through all those points. Whoa. Man, that's awesome. Wow. Wow, 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 wow. Anyways, I'm having fun. So that's what we're going to do today. I'm going to give you 3 points and ask you, what is the circle that passes through those 3 points? where none of them can be assumed to be the endpoints of a diameter or nothing. So that's the challenge. So let's see. Let's do an example. Exemple. Let's say, write the equation of a circle. Of the circle. That makes it sound like even more important. It's a unique circle. There's only one that will be true. It is the Highlander of circles. The circle that passes through these 3 points. Let's see. So let's have one point be 5, 3. We'll have another point be -2, 2. And let's have another point be -1, -5. So, anyone get it yet? No. We have no idea. Do you guys, I mean, we're still going to be looking for the center and the radius. The distances between those points are meaningless to me, right? If I find the distance between this point and that point, it is not a diameter, it's not a radius, it is a chord. All right, it is a, the distance between two regular old points on a circle. Right, so that could be a tiny distance. I don't know how I'd be able to translate that to that. Actually, oh, now you know what I'm super tempted to do? Yeah, I'm going to do it. Well, watch this. If I drew these two chords, this is actually a way to construct circles, and I found the midpoints of those two chords. Chords are C-H-O-R-D-S, chords, the midpoints. And I'm going to construct perpendicular bisectors. Yeah, that's right. By the way, this is the tactic that's used. Imagine that someone is buried in an avalanche at 5, 0, right? And they had one of those little avalanche beacons. This is literally what rescuers would do, because they don't want to just like, oh, let's dig all of the snow off of this mountainside. No, that's probably not the quickest way to figure it out, right? So what they will do is with their little radio transmitters, they will go where the person roughly was, and then they'll get beep, 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 and be like, okay, we're within range, and they'd go beep, 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 and then, uh-oh, we just lost signal. And wherever they lost signal, they'd plant a flag. And then they'd have also planted the flag where the signal first showed up. And then, from that point, they would also walk in a different direction as long as they maintain signal until they lose it again and plant another flag. And what they know they have is two chords, okay? 3 points, 2 chords, and they will find the midpoints of those chords and construct the perpendicular bisector. All right? Now, just that alone isn't helpful. I know that the center will lie somewhere on that, but I don't have a guarantee. I could technically walk, to both endpoints until I lose signal and then find the midpoint again. Or you can actually do the midpoint perpendicular bisector of this, and the intersection of both of those perpendicular lines will always be the center of your circle. So that's actually a tactic that they use to rescue people who are avalanche victims. So there you go. Be safe on those mountains, friends. Be safe. So that's kind of a geometric way to find the center. Let's find the center algebraically. Now, we actually have two equations of a circle, two forms of the equation of a circle. One was standard form, the x minus h all squared plus y minus k all squared equals r squared. That's not actually going to help us today. We're going to use general form, generalissimo, right? X squared plus y squared plus dx plus ey plus f equals 0. All right? And I am going to plug each of these 3 points into this for x and y. And I will have 3 things that are not known to me. I will not know what the coefficient of my x term is. I will not know the coefficient of the y term, and I will not know my constant f. But I will have 3 separate equations for 3 unknowns. And a system of equations emerges that could be solved by substitution, elimination, Kramer's rule, matrices, all sorts of wonderful skills that we have that could be used to solve said system. So let's plug these in. So I'll plug in 5 for x, 5 squared plus 3 squared plus d times 5 plus e times 3 plus f is still unknown to me, equals 0. I'll plug in -2. I'm going to simplify them all together later. -2 squared plus +2 squared. You see what I'm doing? I'm going to get 3 separate equations here. Let's see, e times -5 and f equals 0. Hey, what's up? Welcome, welcome. We're talking about finding the equation of a circle that passes through 3 points. And we talked about how to do it geometrically. And this is how avalanche victims are found when they have a little radio beacon and the people read their signal. They'll use perpendicular bisectors to do it. And now we're going to try to do it algebraically, which is going to be interesting. So
Shouting doesn't always work for me.
No, no, not when you're in an avalanche. So let's see. I've plugged all of these in. Now let's simplify each of these equations. Okay? So let's see. 5 squared, let's see, where'd my mouse go? There it is 25 plus 9 plus, I'll write that as 5d plus 3e plus f equals 0. -2 squared is 4 plus +4 again, minus 2d plus 2e plus f equals 0. Lots of work on this problem. I told you it was going to be a doozy. -1 squared is +1. -5 squared is 25. And then let's see, that'd be minus d or minus 1d, depending on what you want to write. Minus 5e plus f equals 0. So, I'm going to want to solve for d, e, and f. All right? So what we can do is, let's combine these constants and move them to the other side of the equation. So 25 plus 9 is going to be 34. And I'm going to move that to the other side. So 5d plus 3e plus f equals, make sure I'm not making any mistakes here, friends. So 25 plus 9 is 34, subtract it from both sides. We're good. Then I'll have -2d plus 2e plus f equals, let's see, 4 and 4 is 8, subtract that, -8 on the other side. And let's see, -d minus 5e plus f equals 26, so -26 on the other side. And now behold, I've got a system of 3 equations and 3 unknowns. And this is now a problem that I could have given you in the middle of last chapter, and you would have solved it using any number of techniques. What technique do you guys want to use today? What do you want me to do? You want me to go for an elimination? I'm fine doing that. I mean, we've done a lot of work with matrices recently, so we could avoid that. And elimination I don't think is a bad idea. If I want elimination, I'm going to go for opposite coefficients for one of my variables. What would my opposite coefficients, what's my quote-unquote common coefficient going to be? This would be 10 for the d's. How about for the e's? What's 3, 2, and 5 all go into? Let's see, 10, 15, is it 30? Is it really that big? Yeah, it's 30, wow. And between the f's, oh, I think that's the winner right there. So I'm going to go for opposite f's, all right? So I guess I can label these equation A, B, and C. Fortunately, those letters are not yet used by us, conveniently. So let's see, what, I think I'll make B and C my negative ones, maybe. So let's figure out what negative B and negative C are, or -1 times B. You know what I'm saying. So let's see, negative b is going to be positive 2d minus 2e minus f equals positive 8. And negative 1 times c is going to be positive d plus 5e minus f equals positive 26. So, what do I want to do with these equations now? What should I add it with? Yeah, so I'll do equation A minus B and equation A minus C. So our goal is let's eliminate the same variable twice, which will reduce this to a previously solvable problem for us. Okay, let's see. So let's do 5d plus 2d is 7d, not 70, but 7d, right? 3e and negative 2e is e. And the f's, f and negative f, cancel out. Hooray! Yay! And negative 34 and 8 is negative 26. Right there. Let's see. Equation A minus C, 5d and, or plus a negative c, depending on, I don't want you to accidentally think you're subtracting that d there. So 5d minus d, or plus a negative, sorry. I just did exactly what I said not to do. I'm adding these. 5d plus d is 6d. 3e and 5e is 8e. And negative 34 and positive 26. Was that going to be negative 8? I think 4, 8. And the more influential one is negative. Yeah, so clearly for a problem like this, making a mistake anywhere would be disappointing. I hope we don't. But good news, everyone. Look at what I've got. I've got now a system of 2 equations and 2 unknowns. This is like, was it day 2 of the course back when we did that? Wonderful. Or I could rename these, or I don't think I actually even need my labeling system from this point on. I think we're that awesome. Because my labeling system, I would have been tempted to call these equations D and E, which are not helpful since those are also the variable names. I have 2 colors, but not all of you guys necessarily are using 2 colors right now, so it wouldn't be helpful. Maybe all of you are. Maybe you guys are all awesome like that. So let's see. Do you guys want to do substitution or elimination for this system? Or Kramer's rule, I don't know. Elimination. If I was to do substitution, that's a weak spot right there. But I'll do elimination. I'm cool with that. Between 7 and 6, that's 42. Between 8 and 1, that would be 8. Yeah, I don't know. Do I want to multiply this? I probably still have to do that at some point. Yeah, I would have to do that at some point. So I'm going to multiply this by negative 8 to get an opposite coefficient. So let's see, that's going to be negative 56. That's not the right color. That's not quite the right color. Negative 56d minus 8e equals, let's see, it's going to be positive. 8 times 6 is 48. 8 times 2 is 16. So is that going to be 208? Oh, nice. We got it. Oh, add them up. 6d negative 56d is negative 50d. The 8 e's cancel out. Hooray! Equals 200. Guys, I think we're going to find our first variable. How long have we been doing this problem? I lost count. This is amazing. Are you excited? I'm excited. My bamboo tablet is actually just about to die. It's like, please, I'm suffocating in the avalanche. 19% oxygen. And it's like desperate, like, okay, we're doing math up here. We're trying to save you. Okay, here we go. Here we go. They wouldn't actually do all this math if they were trying to rescue someone in an avalanche, just so you know. They would have figured it out the geometric way. 200 divided by negative 50 is, what, negative 4 is it? Mm-hmm. Yay, guys. This is so good. All right. What should I do next? Does this mean my radius is -4? No, we're not even close to that yet. Let's see, what do we do? Where should I plug this? Yeah, either this guy or this guy, because I want to plug it in one where there's only 2 variables, so that'll be able to solve for the remaining guy, right? I like, actually, that top one looks really good because the e's got like a +1 coefficient. So let's see, 7 times -4 plus e equals -26. Let's see, hopefully I have enough room for this problem, seriously. -28 plus e equals -26. E is going to equal +2. Guys, we got 2! Yes! Is that my center? Is my center 2, -4? No, this is not anything even close to that. We still got a ways to go. All right, now what should I plug this in for? D and E could be plugged into any of my 3 variable equations. Actually, this one's a pretty nice one. Or just, yeah, I actually like, actually maybe regular C because that's got a +F and it's got small numbers. Let's do that. So I'm going to plug them in here. Let's see if I can draw my arrow backwards. That'll be interesting. What? Backwards arrow. Wow, that was beautiful. Look at that arrow. I'm proud of myself. So let's see. Equation C was regular old D, so that's -4, right? And that's all I'd memorized so far. Oh, it was a -D. Okay, I can fix that though. Let's see. -5e plus f. So -5 times 2 plus f equals -26. Okay, let's do this. We got this. Here we go. 4 and -10, -6 plus f equals -26. Oh, this is going to be a big number, isn't it? F is equal to, add 6, -20? I hope so. Yeah, I think we're good so far. I don't think I've made a mistake. So I've just found D, E, and F. You've got it. Good call. I'm going to plug D, E, and F into the general form and find standard form. Oh my goodness. This is forever. Okay. All right, here we go. X squared plus y squared. Let's see. D was -4, so -4x. Let's see, D, E, F. I just forgot the alphabet for a second there. Plus 2y minus 20 equals 0. So just to explain what I did here, I plug D, E, and F into general form. Now technically this is an equation of a circle, but if I want to get this to the point of graphing it, I would be interested in standard form. So now it's just like a problem from last night's homework. Finally, hey, we put that coconut back up in the first tree and it's reduced to a problem we've already solved. Wonderful. So let's rearrange this. So I'll have x squared minus 4x blank. I'll have plus y squared plus 2y blank equals, and we'll add 20 to both sides, 20 blank blank. Wow, guys, we know what we're doing now finally. This is like a super long process, but that's okay. We're awesome. So let's see. Find the new C term. I'm gonna cruise through this. Here we go. All right. Divide by 2. Right. So I double complete this square. Now I double factor. I know you guys are trying to keep up. Our internet friends are able to pause the video though, so that's why I'm just like cruising, because this is a long problem. I'll let you guys check all this out later if you need to just follow along for a minute. That's fine. Hey, what? No way. 20 plus 4 plus 1 seriously happens to equal a perfect square? This problem just happens to be super convenient, isn't it? Let's see. So, question, friends. What's the center? Oh! All right. Whew. All right. That would have been sad to get this whole way, and then, like, we dug in the wrong spot, and the guy suffocated. Oh. And the radius? Positive 5, right? Because it's the square root of that. So, not bad, friends. Not bad. And then we could graph that. I'm not even going to graph it now. This video's probably been long enough. Yeah, it has. But I just want to quickly verbally outline what we just did. Okay? So just back to the beginning. Look at this problem. It took like this whole page here. So I was given 3 points. I plugged those 3 points into general form. I was left with a system of 3 equations and 3 unknowns. I solved that whichever way I wanted. I found those D, E, and F. I plugged those back into general form with X, Y not yet plugged in. I rewrote that in standard form by double completing the square. I found out my facts. I could graph it. Wow. Mission accomplished, guys. We solved this mystery. Well done. And bye-bye, internet friends.